Hello, deep learners. I'm Andrew Ng, founder of DeepLearning.AI, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the DeepLearning.AI offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at DeepLearning.AI?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There is never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in DeepLearning.AI, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the DeepLearning.AI community.
So this is our second event for Pine AI Shenzhen. And thanks again to Andrew for the great video. So before I introduce our speaker for tonight, I just want to share with you guys that, if you're interested to learn more about AI, so after this event, there will be the survey email that if you would like to receive a discount code for DeepLearning.AI's course, so please help us to fill out the form, and then you'll get the discount code. And for today's event, our topic is the visual understanding and natural language expression. So we will have the speaker sharing session for around like 40 to 50 minutes. And after that, we will have the Q&A session, which if you have any questions, so feel free to just share in the chat box while the speaker is presenting, or you can just, like raise your hand during the Q&A and he'll be answering. And now I would love to introduce our speaker for today. He is an expert in artificial intelligence in the area of computer vision, machine learning, and reinforcement learning. His research are at the deep learning and other machine learning methods in the computer vision applications, such as the video analysis, human posture segmentation and recognition, or the tracking and serial matching. So I would love to welcome Professor Yuanchun.
Hello, everyone. It's Yuanchun from Tsinghua Shenzhen International Graduate School. It's my great honor here to share with you our recent research work. So the topic about this talk is vision plus language, visual understanding, and natural language expression. I'm from Tsinghua Shenzhen International Graduate School. What is vision plus language about? So vision plus language research, it's about how to train a smart AI system that can see and talk. So in the machine learning point of view, it's a kind of multimodal representation learning, or say multimodal intelligence. And this research topic combining the computer vision and natural language processing communities. And it has attracted rapidly growing attention from both communities. And a variety of tasks, benchmarks, dataset have driven tremendous progress in this research field. In regard to the recently popular tasks, so in the vision plus language domain, arise such as scene graph generation, visual caption, visual question answer, image text matching, text to image generation, and some other vision plus language tasks. And when we look at the statistic information in CVPR 2020 conference, vision plus language is a pretty hot topic and has got much concern in the conference. So that's why in this topic, we will talk about the recently popular tasks in vision plus language domain, including visual scene graph generation, image text matching, visual captioning, visual question answering, visual reasoning. In the conclusion section, we will also leave the takeaway messages, which is also our research plan in our lab. Finally, the question and answer. Let's start our talk with the first task, scene graph generation. So scene graph generation aims to generate structured representation, which are a set of visual phrases: subject, relation, object, and the bounding box for the object in the image. So it's a kind of vision plus language tasks, but it's very basic and the primary task, and can benefit the high-level vision plus language tasks. So in scene graph generation task, there are 3 subtasks. Task 1, relation classification task. Task 2, scene graph classification task. And the task 3, scene graph generation. Here, we will focus on scene graph generation task. Because the scene graph generation can produce comprehensive visual clues and the structured representation, then the individual image object description. So it has got quite concern in vision plus language research domain. Now, there have been many research about this domain. For example, the papers from Facebook, Tencent, and Tencent. But among these approaches, there still exist challenges. Challenge 1, it's a long-tailed distribution of scene graph dataset problem. The relations such as on, has, wearing, off, in, near, and so on, they have much bigger distribution sampling fraction than other relations. So this long-tail distribution of scene graph dataset causes biased generation for scene graph generation task. So this is the first challenge. The challenge 2, we call it the inter-class variation problem. For example, the relation class sit on. In this image, A, B, C are all classified into relation class sit on. But these 3 images has completely different appearance of the image. So this is called drastic inter-class variation. Now, how to deal with these 2 challenges is our motivation. For the challenge 1, long-tailed problem for scene graph generation, we want to design a kind of structure-aware embedding classifier, briefly SEC, with a high-level semantic classification to generate a structured output subspace to classify each relation. Then, with this kind of subspace, we may make the unbalanced data set to a redistributed subspace-based data set. So we can solve the challenge 1 based on the structure-aware embedding classifier. For the challenge 2, challenge 2 is the problem of inter-class variations. Even the sit-on relation has totally different visual appearance in the different images. But we find that the objects connected to the relation of sitting on has very similar semantic feature and structure representation. For example, the object, street, and sidewalk. Both objects related to sitting on or walking on has very similar higher layer semantic architecture or structured representation. So based on this kind of similar higher level semantic structure, we designed a kind of hierarchical semantic aggregation module in scene graph generation model. With this hierarchical semantic aggregation module, we may generate a kind of layered multi-level semantic expression. The figure shows the semantic hierarchy of VG dataset and VRD dataset respectively. Then, with this hierarchical semantic aggregation module, we may alleviate the problem of inter-class variations in scene graph generation task. Here are the framework of our model. The SEC, which is structure-aware embedding to classifier, generate the subspace-based result to be combined to generate the final scene graph output. And the hierarchical semantic aggregation can be used to deal with the intra-class variation problem. The experimental result shows that our model achieved better performance than the previous models. And this work has been published in ACM Multimedia 2020. This Ablation study also illustrates the functions and the benefit of our model based on SEC and HSA modules. Now we turn to another task, which is also a very interesting and basic vision plus language task: image text matching. Image text matching aims to get the matching between the image and the text. It has two subtasks. Task 1 is to search images for given sentences. Task 2 is to retrieve sentences related to given image. So we can take use of the image text embedding method to achieve the matching task. The key or the core of this task is to infer fine-grained correspondence between visual instance and texture concepts, which makes learning instance-level visual features foundational to this task. In previous work, there are two main methods. One is a detection-based method. Another is attention-based method. Detection-based method has advantages of straightforward. It extracts visual features directly from region proposals. But the limitation about this kind of method is it is neither an end-to-end learnable requiring extensive annotation nor adaptive to unseen instance. For the attention-based approach, the advantage is it is a global attention method and sequentially attend to different visual semantic in fixed steps with global context. But the problem is it is not flexible to handle situations where varying numbers of instances exist in different images. So it is not flexible. So our model is designed to be an end-to-end and adaptive model to aggregate instance-level semantics from all potential positions. These three images, A, B, C, figure out the relationship among the three methods. For detail, we can find that in our model, there are three components. One is the visual component by the ResNet to get the visual feature of the content. And the textual feature is obtained by the RNN. And the feature fusion component is to do the multi-scale aggregation for the multi-scale feature by the self-attention components. And finally, we do the similarity measurement based on ranking loss. And the stacked cross attention is also adopted. The performance of our model is also better than the previous models. The experiments are conducted by the Flickr 30K and MS COCO dataset separately. Both achieve state-of-the-art performance, and this work has also published. And this is the attention map of our model. Each attention map has 4 images. The first image is 3 representative regions with red color bounding box. And the other 3 images is the attention map corresponding to each red color bounding box. We can see that the attention map have very good correspondence corresponding to the original bounding box. So this work have been published in ACML 2019. Next, visual captioning. Visual captioning aims to describe the content of an image or video with a natural language sentence. It is also a very basic task in vision plus language domain. There are 3 subtasks. One is the image captioning. Another is video captioning. And the video event captioning. So what's the relationship between among these 3 tasks? Image captioning is a very basic task to give a natural language sentence for one image. But the video captioning is to give just one sentence to a video sequence. And the video event captioning should represent each event of the whole video sequence. And the video and the events may be overlapped. So video event captioning is much more complicated than the previous 2 tasks. The image captioning is a basic task for vision plus language task. Before the emergence of deep neural network, the image captioning is modeled by the previous machine learning algorithms. For example, descriptors, support vector machine, conditional random field and the rule, and so on. The first image captioning model based on deep learning was proposed in 2015 by SAVEY research group. It is structured by CNN and RNN. Here is LSTM. CNN used to get the video appearance, the image appearance, and LSTM used to generate them. So in our model, we bridge the 2 gaps by 2 schemes. One is to narrow the gap between the visual features and the textual semantics. And an attention-based reconstruction module is designed to represent the visual feature of each image region with the corresponding high-level concepts predicted by the object detector and attribute classifier. And the second, to bridge the gap between the disordering of visual feature and the ordering of textual sentences, an attention-based pointer network is presented here. Now, for details, this is the model architecture. The semantic reconstruction part has the attribute classifier and attention-based reconstruction module and vision to language attention component. So in the semantic reconstruction component, we may do the attention-based reconstruction function. And the ordering plan include attention-based pointer network and the multi-head attention-based encoder and the multi-head attention-based decoder. And in the order sensitive encoder part, it has a position encoding module. Finally, output the sentence. The experimental result can also show that our model has very good performance in the MS-COCO data set. And this work has also very good performance for the case study. Here, there are 6 examples for case study. In each example, three part result, 3 output. One is the baseline model output, which is the AOA net model. And the next is our model. Third one is a ground truth. Compared with the baseline model, which is the AOA net, our model can get better performance. For example, in example B, the baseline meets the object ocean. So it has the problem of information missing problem. And for the example A, the baseline output result is a man standing in a field flying a kite. And our output is a group of people flying kites in a large field. So that means that our model can get better performance for the correct concept of the image. It is in this image, it is not a man standing, but a group of people. This work has been published in Calling 2020. Now, we move to the task of video event captioning. Video event captioning, it's more challenging than image captioning because of the uncertainty of event measurements, as well as generate context-aware sentences. For example, here, the video event captioning. The second sentence is for the event, a woman walks to the piano and briefly talks to the elderly man. And the third event is the woman starts singing along with the pianist. So here we should figure out that this woman is the same woman as the second event. So this is a context-aware sentence. So in video event captioning, the key is to generate the correctly use words such as another and continue when the context for multiple events. So for our contribution, we design a hierarchical LSTM-based encoder component for video event captioning task. In the hierarchical LSTM encoder, we use the lower layer to get the inter-event feature expression, and use the higher layer LSTM by the attention part of the decoder component. Architecture of our model. It is based on hierarchical LSTM encoder. Our model also achieves the state-of-the-art performance in the dataset. We can correctly generate the continuous and some difficult situation, which is the complex context multiple event situation task. Finally, the visual question answer. Visual question answering is also a very important vision plus language task. The first data set for visual question answering was presented in 2015, which is the VQA dataset. For example, given the image, and the question is, who is wearing glasses? The correct answer is man and the woman, respectively, for the two images. So that's visual question answering. From 2015, there are tremendous progress in the dataset or benchmark in visual question answer research domain. For example, VQA, VQACP, VCR, and the STVQA dataset. And this benchmark or dataset has made tremendous progress in this field. And the video question answering is more difficult or challenging than image question answer, because it aims for high order reasoning over spatial and temporal contents of video. For a video sequence, we given a question, what are some guys playing in the ground? The correct answer is football. There are also some methods for this presented for the task. For example, HME model and the COM model. The HME model was presented in CVPR 2019 by Jingdong, and the COM model was presented in CVPR 2018 by USC. In video question answering task, there are two main methods. One is the RNN-based methods. Another is self-attention-based methods. The challenges for RNN-based methods, it tends to forget the global semantic contents due to the inherent drawbacks of the recurrent units themselves. And for self-attention-based methods, it cannot precisely capture the dependencies of the local neighborhood, leading to insufficient modeling for temporal order. Then we design our model based on the two challenges. we designed a fine-to-coarse architecture. And there are two fine-grained feature augmented memorize are introduced to strengthen the information augmentation of video and text, which can improve the memory capacity by memorizing more relevant and targeted information. And we also present the self-attention and the co-attention module. Those are appended to the memory output. Thus, the module is able to capture global interaction between high-level semantic information. This is a framework of our model. Now, in this model, there are three groups of LSTM used to learn the motion, appearance, visual, video, and word embedding, respectively. And then the augmented memories. One is the textual text augmented visual memory. Another is video augmented texture memory. And the non-local component is used to learn jointly learn the two features together. And finally, use core attention module to get its output. For the fine-grained feature augmented memory, text augmented visual memory is to memorize the important text, which is most important related to the video. And the video augmented textual memory is used to memorize the most important texture, which is most relevant to the certain video. And our proposed models also achieve the state-of-the-art performance in 3 datasets: TGIF-QA, MSVD-QA, and MSR. So this, we can find the case study. This is a case study of our model. In this video sequence, there are 3 actions. A man lifts his opponent and throws it to the ground and punches his face. So in this video sequence, there are 3 actions. The question is, what is a man doing after lifting his opponent before punches his face? We know that the answer is throw. In this image, we can find that the self-attention weights for sequence can have very clear attention result for the lifting, because the lifting is important in question. And self-attention weights for video is a video sequence for throw, because throw is the right answer. So that means our model can get the correct correspondence for the question and the video feature. And this work has also been published in EJKai 2020. Now we move to the last task, visual reasoning. Visual reasoning is also a very challenging task because we should reason the world, visual world. We should reason the visual world like human, and to responding to the natural language question, and then to give a correct answer. And Clever is a data set for compositional language and elementary visual reasoning. And it has been extended to visual dialogue, referring expressions and video reasoning. For example, here, given an image, the question is, are there an equal number of large things and metal spheres? The model should learn and give a correct answer. The film model is a very important model for the visual reasoning task. And PG plus EE model is also a very important model by Google, published in 2016. And our motivation, the motivation of our work is based on the batch normalization technique. Batch normalization technique is a basic module for deep neural network. And it normalizes the actionality of whole network for mini batch. And in visual reasoning task, conditional batch normalization components have been frequently used. For example, in film model, it has a affine transformation algorithm for this conditional batch normalization algorithm. Our improvement for this conditional batch normalization module is to take use of Kronecker transformation algorithm to make a kind of conditional Kronecker batch normalization and to give more conditional parameters, and then to get a higher reasoning performance for visual reasoning task. Now, it is the network architecture of our model. It has two pipelines. GRU pipeline is used to train the question, and the visual pipeline is taking use of ResNet 101 plus the CKBN, that's a conditional Kronecker batch normalization module, which is our main contribution. With these two pipelines, we may get a higher performance reasoning result. This is the comparison result about our model and previous models. And our model can achieve the state-of-the-art performance in the visual reasoning task. This is an ablation study and also demonstrates our model has very good performance for clever human dataset and the clever hand dataset. Now, this is a comparison between our model with the film model. In this example, we give an image. We are given an image. And the right part is the Koronek conditional batch normalization method, which is our proposed method. We can obtain the total objects related to the question. And the left side is the result of film model, which just obtain the parts of the correct answer. And this work has been published in BMVC 2018. Now, we draw the conclusion of our talk. Vision plus language is an emergent and rather interesting research, and a variety of tasks, benchmarks, and data sets have driven tremendous progress in it. In the machine learning point of view, it is a multimodal representation learning, or say multimodal intelligence. There are many research topics involved to be exploited and explored. For takeaway messages, multimodal represent can be learned by transformer-based module and plus some additional components, for example, ODE, PDE, and flow modules. And the second direction of our research is to do the visual language, move to audio visual language task, because it is a real multimodal represent learning like human. Okay, that's my talk. So vision plus language task is a kind of treasure miner waiting for your digging. Thank you, everyone.
Okay, so let me just stop the PPT here. Oh, maybe we can keep it first. Okay, so we have to apologize again because I think we had some technical problem. But however, thanks to the professor again, because I think we learned a lot about the computer vision and also the natural language expression. So if you guys have any question, then feel free to send in the chat, or you can raise your hand and you can ask a question. If there's no question, then maybe you ask the professor. So can you please share a little bit better what was your recent papers that you were reading? Like, is there any paper that you want to share to the audience here?
Yes. In fact, here I have introduced our recent work published in 2019 or 2020.
Right.
Yeah, you can download all of these papers on website. So if you want to ask for any details, it is welcome to contact me directly. No problem. You're welcome.
Yes. Someone was asking if we can share the PowerPoint after the meeting.
Yeah, okay. No problem.
Yes. So are you guys in the WeChat group, or how do you want us to share the PowerPoint? Mr. 1111, are you in the WeChat group? Okay, so in the WeChat, understood. Okay then, so we will share there. Yes, you can leave your email here, and then I'll email to you as well. Okay, so if there's no any other question, then I think this is it for today. Thanks again, Professor.
So sorry for the network problem.
We will always have the event pretty much like almost every month, and then so I'm not sure how do you find out about this event, but well, in Eventbrite, so you can follow Pi and AI community, because there will be, you know, like maybe 400 cities around the world right now, and then Shenzhen is one of them. So yes, that is also another way to follow us. And as I mentioned, since we are in China, so we are having the WeChat group. So if you have WeChat, then feel free to join us as well. So yes, Masha, you can leave your email in the chat box, and I will follow up. Okay then. Bye guys. Have a good day. Have a good evening. Okay, thanks, Tanver.